For this section over linear regression, I wanted to jump into the computer screen and just kind of show you steps and processes. This section is more of using information we've already done in a larger data sense. And so we're going to use some tools. Now, the tools that we're going to use in this section, you will have available to you on your computer while you test. So you definitely need to know how to use the ins and outs of it. So we are going to be looking at linear regression. What is linear regression? This is just a matter of taking your data and then seeing that a linear pattern is occurring and figuring out the line of best fit on average for that situation. So let's just say the line of best fit for the given data set. And so we know how to find slope between 2 points. We know how to find y equals mx plus b situations with two set points and things that are really nice. And so what we're going to do is kind of take a lot of data that looks to be in the same format of this and create an average of what's going on with that. So we're not going to use that by hand and go, okay, 2 points, 2 points, what's going on? We're going to use technology to help us with this. And so what we're going to use for this one is Google Sheets. Google Sheets, it does also occur within Excel, but Google Sheets is an online platform. You have Sheets available through your Panola College student email because it's set up as a Google format. So everyone has access to Google Sheets. And so that's why we're going to work with that purpose. And again, you will be given a link into Google Sheets for this section. And so what we're going to do is I'm going to show you the steps and show you what's going on with that. Then I'm going to show you how that works in an application sense in this example. This homework set is not a long section. You're not going to see 25 questions or anything like that, but it's a matter of you figuring out how to use Google Sheets to help you with that line of best fit or linear regression. So here's going to be your process with the Google Sheets. You're going to copy your data into Google Sheets. So whatever the given problem is, it's going to be in a table format. We're going to take that format. We're going to make sure it fits this situation of linear that we're looking like. We're going to do that by step 2, inserting a chart or scatter plot to check if it's linear. Because if we're looking at data and it is not linear, it does not matter the line that we get. It is not applicable to our situation. Then, because we can look at a pattern of what's going on, we're going to find the line that goes to the data. We're going to do that by linear regression. Again, I'm going to walk through these steps and then we're going to rotate back and forth between our notes and the sheets so you can see how this outputs. So in order to find the line to data, because you are taking notes, you are writing this down, in order to find linear regression, you're going to be looking at typing in the command of equals LINEST, lineist. This is a command that you will have to know. You will have one of these on your exam for this unit. What this is going to do is we're going to take the data, we're going to tell Google Sheets to find us basically the line of best fit. And the information we're going to do is we're going to do this command equals lineist open parentheses. And the first piece of data that you're going to do is you're going to fill in your Y values or your outputs. And it's important to note this because typically we always see X come first if you think about ordered pairs, but actually you have to align your Y values first. Then after you get your Y values in there, you're going to do comma and you're going to select, and again I'm going to show you this process, your X values or your inputs. And so this is how you're going to set up this command. You're going to have lineist, and then these Y values, and I'm just going to kind of highlight this, are going to be what you select, comma, these X values, and that's going to be what you select. Okay, so these are not something I'm going to hand type in. I'm going to select, I'm going to show you that process. Once you get to that point, what it's going to do, it's going to give you two boxes, and it's going to give you the slope, and it's going to give you the y-intercept. So when you're looking at the slope and y-intercept, you can see that's the information you need. And then because of our knowledge from the previous parts of this unit, we can do y equals mx plus b with those two pieces of data. Okay, so this is going to be the process. It's kind of a three-step process. We're going to copy it in. We're going to make sure the data looks like a linear function, and then we're going to have Google Sheets create that linear function for us. The outputs that it's going to give you is these two outputs here of slope and intercept, and then we're able, because of our knowledge, to create that line. Now, some situations are not going to be linear. Some of them might be exponential. So just for knowledge sake, when you're looking at an exponential regression, you can see the command is different. You would enter equals logist, and then again, you would follow through with your y values, comma, your x values. Not that you type them in, but that you take this. I'll just kind of highlight for similarity. You would just type, select these. And then what it does is it gives you two pieces of information. It is giving you the growth factor, and then it also gives you the initial value. The setup for something like this, we have not done a ton with it, is y equals ab to the x. And so I don't want you to assume that all of your data fits into a linear form, but that is what we're going to look at the most because of what we've been working up into. And so really there's not a whole lot of notes to be taken for this, but it's a matter of knowing your steps and your processes and then execute that. And so what I want to do is I'm going to open up my Google Sheets. Again, you can go through your student email for Panola College, and then you can click on the side in order to get into your Google Sheets. I will also include a link to Google Sheets from your homework assignment as well as your exam. So I'm going to come up here, and this is my Google Sheets. I've already kind of preset this up. So I have a couple different examples we're going to work through today. And these are just the table that was given in the example. And so what you're going to do is you're going to copy and paste this into here. You can see that I have I'll label them for us. So these are my X values and these are my Y values, and this is going to be given to you just like this as a table in your assignment. And then what we're going to do is we're going to follow our steps. So let's look back at our steps. We're going to copy the data into Google Sheets. I've already pre-done that. Then I'm going to insert a chart. And so how do you do that? You want to select your XY axis, or your X and Y inputs. You'll go to insert, and then you can see we have lots of options. We're going to do chart. Now when you click on chart, it's going to pull up some different options here. I've already been kind of playing around with this. It may default into a line chart. If it does, you just click on here and choose the one with the different dots on it. This is our scatter chart, and so what it's doing is it's plotting each XY value as you have them paired up within the row. The important part of this is so that I can see this has a linear movement. It looks like averaging over this data, there could be a line that's created in here. You can see that my X's are down here at the bottom. My Y's are over here on the side, just like what we see with our coordinate plane. And so you always want to kind of first check your data, because if these dots are all over the place, there's no point in me finding a linear regression. Okay, so in our steps, we're going to insert the chart to check if the function is linear. And you can see I've done that here. I can X out of this component, and you can see I've still got my graph going on here. Okay. Then what you're going to do, step fit line to data. And so we're going to use this command here of line st. So I'm going to come over here and I'm going to say equals. Now it's ready for a command, linest. You can see it's already starting to like assume what you're doing, so you could click on that. I'm going to do an open parentheses. Now it's ready for the next part. Now you do have to put the equal sign. The next part is, remember, we're going to be looking at Y values, comma, X values. Kind of reverse of what you would think. So I'm just going to click and drag to select those Y values. I did not select the Y. I clicked and dragged down to here. And if you're not using a mouse, you're going to have to see how to do that with your laptop. So then I'm going to hit comma. So you can see, look, those colors have changed. That was an input that I did of comma. Then I'm going to select my X value. So I'm going to click, hold down my mouse, and drag down to here. And once I do that, you can see it gave me a span of values from A2 to A12. And then I'm going to close parentheses. I'm saying, okay, I'm done. And then I'm going to hit enter. So it's given me two values. What are these two values? This is my slope, and this is my y-intercept. So if I wanted to know the line of best fit, or the average of the line that's coming through this data, that would be y equals mx plus b. So that means that would be y equal to, I'm going to round, negative 2.605 x plus that y-intercept, 45.364. And so this would be the linear function that would average out or run right through these data points to predict what would happen later on in the graph or at a point that I haven't calculated. So again, looking back at our commands here, you can see that I'm going to have equals, L-I-N-E-S-T, select your y values, comma, select your x values, close parentheses. It's going to output these two answers, but it didn't tell you what those are. Again, this is your M and this is your B. You have to know that's what those are. You have to know this command. Then you're able to answer that. So technology is really nice. It can look at a large data set, in this case 10 different values, and estimate out what the line of best fit is. We don't have to do 2 points, find the slope. 2 points, find the slope. I'm looking at it in a general sense the entire way. Now I want to do that again with you. I'm not going to click back and forth between the notes. So I have another example down here with this data set, and you can see that I have a very large set here, and you're going to encounter that. These are not very nice numbers. There are a lot of decimals going on here. Again, this is my x value, this is my y value, and I just pre-copied this in here for time's sake. So what I'm going to do is I'm going to say equals L-I-N-E-S-T. Oh, excuse me, I forgot step 2. Let's check this data. So I'm going to select these two, insert, chart. It gave me a scatter, but if it had been a line chart, all I would have to do is click on the one with all the dots. And you can see that this is what this chart looks like. And so I can see that it looks like it's going up. It looks like it's in a linear fashion. You can see my x's are down here, my y's are over here. So I have verified that I am looking at a linear situation. So I'm going to say equals L-I-N-E-S-T, parentheses. Again, select, click and drag to select those y values. Even if you, I'm going to do comma. Now I'm going to select my x's. So if I click on this one and I don't drag, you will have to, you can grab that dotted line and pull it down after the fact. And that might be more user-friendly if you're not using a detached mouse, maybe using a mouse pad on a laptop. And then you'll close parentheses. Now you can type these functions telling them A15 to A29. It just tends to be a little bit easier to click and drag. And then hit enter. And then you have to know this is your M, this is your B. So that means my equation or linear function that best fits this data would be y equals 2.826x plus 12.161. And so this is the equation best fit for this data that would run right through here. We can see that makes sense. I have a positive slope. My data is going up. It has a y-intercept of 12-ish, so we can see that makes sense with these relations. It's kind of closer to the 20. Okay, I'm going to do one more example for you, and then you need to go and try this on your own. Again, the homework is not super long, but you need these steps to work through that. Okay, so again, lastly, steps. Copy the data, insert a chart, fit the line to data. You'll have to know this command, y's, x's, and the results that it gives you. And so I'm first going to x, y. I already have my data in here, so I will select it and then go to insert, chart. It's already on scatter because I've been doing this on repeat, so I can see that looking at that chart, it looks really nice, looks really straight lined for me. So I do have a linear situation. I'm going to do equals, L-I-N-E-S-T, open parentheses. I'm going to select my y's, comma, select my x's, close parentheses, hit enter. So this gives me my M, B. So in this one's really nice. I would say y equals 9x plus 2. So go and try this. I've also posted some resource videos within the lecture page. And then reach out to me if you struggle with that, and we can do additional help from there.